Hi, welcome to CSEMA. In this video, we are going to learn about Terraform. So before starting to what is Terraform and why it is used, let's take a look at outlines that we are going to cover in this video. Firstly, we will start with the introduction to Terraform, like what is Terraform and why it is widely used today. And then we proceed further and cover the infrastructure as a code part, like why infrastructure as a code. And then we take a look at features of Terraform and how exactly Terraform works. And then we know, then we learn, then we know about the Terraform providers. And then at last but not least, we will take a look at the basic commands and supported versions of Terraform. So without wasting the time, let's start. And if you are not yet subscribed to CSEMA, please do subscribe. Terraform is an open source infrastructure as a code tool created by HashiCorp, and it is a declarative coding tool that allows you to build, change, and version infrastructure safely and efficiently. And it also enables developers to use high-level configuration language called HCL, HashiCorp Configuration Language, to describe the desired end state, cloud, or on-premises infrastructure for running an application. This includes low-level components such as compute instances, storage, and networking, as well as high-level components such as entries, SaaS features, and so on. Then it generates a plan for reaching that end state that we described in a SCL and executes the plan to provision the infrastructure. Terraform uses simple syntax and it can manage both existing service provider and custom in-house solutions. It is currently one of the most popular infrastructure automation tool available. And if your organization planning to use this to deploy a hybrid cloud or multi-cloud environment, you will likely want to need to get to know about Terraform. And currently, it provisions infrastructure across 300 plus public clouds and services using a single workflow. Before going further on a Terraform features and all, let's take a look why we should use infrastructure as a code, IAC. It will help us to understand the advantages of Terraform. After all, Terraform is a IAC software tool. IAC or infrastructure as a code allows developer to codify infrastructure in a way that makes provision automated, faster and repeatable. It is the key component of the Agile and DevOps practices such as version control, continuous integration, and deployment. And features of the ISS are like improved speeds, it automates the deployment, and it also improved reliability. Resources are always provisioned and configured exactly as declared. There is no any misconfigurations while declaring the object and provisioning the resources. IAC prevents configuration drifts. At a high level, configuration drifts happens when production or the primary hardware software infrastructure configuration drift or become different in some way from a recovery or the secondary configurations or vice versa. And at last one is the support experimental testing and optimization. IAC allows that testing experimental changes can be done quickly and efficiently with less time and less resources. Now next, let's take a look at the features of the Terraform. Like why these all features made it more effective and widely used these days. It has all the features of the IAC that we just covered that are improved speed and improved reliability. It also prevents configuration drifts, supports experimental testing and optimizations. And in addition to this, it is open source. Means Terraform is backed up by large communities of contributors and practitioners who build plugins to the platform that improves speed and reliability. Regardless of which cloud service provider you use, it's easy to find plugins, extensions, and professional support. This also means Terraform evolves quickly with the new benefits and improvements added consistently. And platform agnostic, meaning a Terraform can be used with any cloud service provider. That can be Microsoft Azure, AWS, IBM Cloud, and GCP, and many more. And next, take a look at working of Terraform, like how Terraform is works. Terraform allows infrastructure to be expressed as a code in a simple human-readable language called SCL, and SCL stands for Hashi-Curve Configuration Language. It reads configuration files and provides an execution plan of changes, which can be reviewed for safety and then applied and provisioned. And as the configuration changes, Terraform is talented enough to decide what changed and generate incremental execution plan which can be practical. Terraform is backed up by the large community of the contributors and the practitioners who builds the plugins to the platform. You can use it to plan and apply to your infrastructure. It has more than 1,000+ providers. Regardless of which cloud providers you use, it's easy to find plugins, extensions, and professional support. This also means Terraform evolves quickly with the new benefits and improvements added consistently. And extensible providers allow Terraforms to manage a broad range of resources, including IaaS, PaaS, SaaS, and hardware services. Okay, next we'll take a look at the Terraform providers. Terraform providers are the plugins that implements resource types. Providers contains all the codes needed to authenticate and connect to a service, typically from a public cloud or on a behalf of a user. Terraform relies on a plugins called providers to interact with the cloud providers, SaaS providers, and other APIs. Terraform configurations must declare which providers they require so that the Terraform can install and use them. Additionally, some providers requires configurations like endpoint URL or the cloud regions before they can be used. Each, pro- each provider has its own documentation describing its resources types and their arguments. And it adds a set of resource types and data sources that Terraform can manage. Every resource type is implemented by a provider. Without provider, Terraform can't manage any kind of infrastructure. Let's start with the Terraform basics, commands, and supported version. So we have listed out here a few basic commands that we can use while interacting with the Terraform. First one is the Terraform version. Terraform version is used to check the installed version of the Terraform in your cloud resource. And Terraform destroys. Terraform destroys used to destroy the managed infrastructure of Terraform. And next one is the Terraform FMT. It is used to rewrite configurations files in a canonical style and format. Then we have Terraform providers. It gives information of the providers working in the current organizations. So these are the four basic commands we can use to identify the Terraform versions, and we can also find out what providers it's currently using. And the next we have is the supported version. Terraform supported multiple versions. We have listed few here. That is github.com, gitlab.com, GitHub Enterprise, GitLab CE, and EE. Then the next one is the Bitbucket Cloud and Server. And we have Azure DevOps Server and Services. So now let's recap what we have covered in this video. Let's start with the definition. Terraform is an open source IAC software tool that allows developers to build chains and version infrastructures safely and efficiently. And next we have the IAC, infrastructure as a code. IAC allows developers to codify infrastructure in a way that makes to provision automated, faster, and repeatable. And it has all the features. Terraform has all the features of IAC, and in addition to that, we have more like open source, and it's platform agnostics. It can be used with any kind of cloud providers. And Terraform uses human readable language, basically the declarative codes called SEL, HashiCorp configuration language, to get the desired state. This complete line can be used to describe the how Terraform actually works. And next we have the Terraform providers. These are the logical abstraction of an API. Upstream API, they are responsible for understanding API interactions and exposing resources and plugins implement resource type. This is all about in this video, and thanks for watching, and I hope you must subscribe to CSEMA. Thank you.